Hey, how's it going? Alright, Leetcode 691, n repeated element in size 2n array. You're given an integer array nums with the following property. Nums.length equals 2 times n. Nums contains n plus 1 unique elements. N plus 1. Oh, okay, got it. Exactly one element in num is repeated n times. Return the element that is repeated n times. So I hate questions like this because what I want to do, what the natural thing to do is to use a counter and figure out what the one thing that appears a bunch of times is. But that's not what they want you to do. They want you to go nums.sort and then what is the max last, and so it exactly one element is repeated n times, so that's n equals nums divided by 2, right? So the last one that it could possibly be what should we call it, min last, is that one. Or if it were going from the other direction, the max first that it could be would be, so if let's say that the last element was n times 2 minus 1, right? And then so plus 1 minus n, right? And then these cancel out. N times 2 minus 1. Trying to think here. Are these like secretly the same number? Yes, they are. So the max first is this. So one of these two is the number that we're looking for. It's kind of what I thought. So we have to find out which one of these is repeated at least once. Okay, so what we're going to do is we're going to say if nums of min last equals nums of max first, then we have found it, right? Because usually if they're like somewhat random, then the number that you're looking for is going to be in the middle. Otherwise, it's one of these two and we don't know which it is. So let's make sure that we're not going over. Well, no, we can't go over. It's impossible to go over. Then return this. So that's it. Otherwise, it's one of these two. So min last equals min last plus 1. And then, you know, the problem is going to be what? N log n complexity or something like that. Return. Okay, hopefully I did this right. Otherwise, not to look really stupid having complained. List and in. Oh. Why didn't you tell me? Alright. Will it pass muster? Oh, shit. Output 5? What? Alright. Well, maybe I'm not as clever as I thought. Print nums. Print min last max first. And since we're here, did I do something? Well, we'll see. We'll see. All right. So this is incorrect, apparently. 3, 3, 5. So 1 and 2. So this is exactly the case that I was supposed to be coding for. What in the... Oh, I typed the wrong thing. Oh, God, I was so confused for a second there. I'm like, what in the hell is going on? Okay, so it should be... It is finding the 3. So this is exactly what I was thinking. The min last, right? So... if min last equals max first, which it doesn't, then we do min last. Okay. Min, crap. There we go. There we go. If I had just gone the other way, the +1 would have worked. Oh well. Oh well. Okay, so my theory was right. I just, what in the... What is going on? Why is mine so slow? What are other people doing? Python 3, extra space solution. Silly question, pay attention to the details. Nlogin is what I did. Use of counter. You know what? I'm curious. I am curious. If we just C equals counter of nums. This is what I wanted to do. For C comma V in counter of nums dot items if C is greater than 0 return V. This is what I wanted to do. As I was saying, this is what I wanted to. What is going on? Did I get these backwards somehow? Print C comma V. God, this is really making me look bad today. 1, 2, 3. If C is greater than 1, return V. Jeez. Let's see what the speed is of this. No, it's still... People are kicking my ass here. What? Bit manipulation. Basically, you need to find an element that repeats at least one time. That is true. Oh, that's a big old mask. What is the range of values? I mean, yeah, you could do that, but I mean... Mask equals 0 for I in nums. Maybe a giant bit field makes perfect sense. So bit mask equals 1. There's no negatives, right? All right, cool. So if bm and mask, then return I, else mask or equals bm. There we go. All right. Okay. Well, that sucked, but we figured it out. And also, I thought having a multi-thousand-bit integer would be inefficient, and apparently I was wrong. So I learned something. All right, see ya.